In this video, we're going to talk about the properties of acids and bases. So, acids typically have a sour taste. Like if you bite into a lemon, that sour flavor you get is the result of citric acid interacting with your tongue. So, what acids do in general is they donate a hydrogen to water and form what's called a hydronium ion, H3O plus. A lot of times you'll also just see this represented as H plus, but it does in fact get carried around by water in a solution. Acids we know have a low pH, so below 7 is an acidic pH, and we know that we can use litmus paper to test how acidic or basic something is, or pH paper, and in general acids will turn the paper red. Acid, red. Acids, like bases, will also conduct electricity. So when you have a battery, you have battery acid in your car batteries. You can also have alkaline batteries, which are basic solutions. They both conduct electricity. See here, acid conducting electricity. And see here, a base conducting electricity. So now let's talk a little bit about bases. Bases tend to generate a hydroxide ion in solution. So now this can happen in a couple different ways. One is if you have an ionic basic salt that you put in water, like a metal hydroxide, that will dissociate. It's a little bit different than the acid because it's not an ionization. The particles are already ions, so they just separate and dissociate when you put them in solution. But a basic solution tends to have a buildup of hydroxide ions. So that's the defining characteristic. Acids will have a buildup of H3O plus, and bases will have a buildup of hydroxide ion. So bases, just to go over a couple more properties about them, they tend to make blue colors on litmus paper or pH paper, and they can react with acids to neutralize them in double replacement reactions. But if you were to taste a base, it would be like soap is usually a little bit basic. That nice bitter taste you get when you bite into a fresh bar of soap, well, that's the bitter taste of a base. All right. So now, before we go any further, I want to talk a little bit about water because it's really all based on that. Water in itself is actually both an acid and a base, just in very small quantities. In a sample of water, the vast majority of the molecules are going to be in the form of H2O. But a small amount, like on the order of 10 to the negative 7th molar, will actually autoionize. So what will happen is one water molecule will donate a hydrogen to another water molecule, thus forming an H3O plus or hydronium ion and leaving behind a hydroxide ion as well. And we'll learn in another video about the pH scale that the product of these two molarities is always going to add up to 10 to the negative 14 for an aqueous solution, whether it's acidic or basic. Okay, but so water, very, very low concentrations of these ions. If you have a strong acid, like hydrochloric acid that we've used in the lab this year, all of it is going to essentially ionize. So every molecule of HCl you put in a sample of water is going to break apart into a hydronium ion and a chloride ion. And similarly, a strong base like sodium hydroxide, which we've used, all of them are going to dissociate. Okay, so for every one formula unit of NaOH you put in, you're going to get one formula unit of sodium ions and then hydroxide ions at the end. However, not all acids are strong acids, and not all bases are strong bases. So if we compare a strong acid and a weak acid, strong acid, we said, ionizes 100% of the time. Weak acid is only a small portion of the time. You can see here that most of them remain in the unionized form, and a very small portion of it is going to remain in the ionized form. Weak bases are a little bit different, however, when we're comparing them to strong bases, because strong bases are metal hydroxides, and you can see that that's just going to be a dissociation. However, a weak base is a little bit different, because what actually happens is the base will essentially accept a hydrogen from water and form what we're going to end up calling its conjugate acid, but essentially it accepts a hydrogen ion and becomes positively charged, and in